Welcome back. In this video, we're still in the concentration measurements, but we will answer the question with the assumption. Again, before we start, we need to read the question and differentiate. The information given is referred to solute, solvent, or solution. Given a density of 1.769 gram per mole and a H2SO4 mole fraction of 0.5. Find the molarity. So this is the case of H2SO4. As we know, it is an acid. So acid always show its property with the presence of water. So basically, this is the density for the solution. Okay, and then with the mole fraction H2SO4. Find the molarity. So yes, as usual, we list down the formula for the molarity, which is equal to mole H2SO4 divided with the mass H2O in kilogram. Next, we will expand the formula of the density solution, which equal to mass mass H2SO4 solution over volume H2SO4 solution. So in this case, we only have the density gram per mole, and we have no idea about the mass of solution and also the volume of solution. If this is the case happen, means that we cannot use this formula to help us to get any information yet. So we proceed to another, which is the mole fraction. Okay, mole fraction of H2SO4 equal to number of mole of H2SO4 divided with number of mole of H2SO4 and number of mole of H2O, because the H2SO4 solution is made up from the H2SO4 dissolving in water. So again, for this question, we have 0.5 mole, 0.5. Again, we have no idea the mole of sulfuric acid and also the mole of water. So when this is the case happen, we are going to do assumption. Okay, if you compare to the previous video, you will notice that we try to expand the formula, but in the formula, we have two unknown. Another formula also have two unknown. When this is the case happen, we need to do assumption. Then next you may ask, what should I assume? So normally we will ignore the density. Okay, for me, I will always ignore the density. We look at the mole fraction here, another one. Okay, so for this one, I will going to compare that the total number of mole will equal to 1 mole. Okay, in this case, we will assume n total equal to 1 mole. Okay, so then we use the formula mole fraction of H2SO4 equal to 1 mole, and then this one is number of mole of H2SO4. Given the question is 0.5. So then from here we know number of mole of H2SO4 is equal to 0.5 multiplied with 1 mole, which is equal to 0.5 mole. Okay, then next we will check. We are looking at the molarity, which is mole H2SO4 divided by mass H2O in kilogram. So at this moment, we already settle for the mole of sulfuric acid. So next, we need to know the mass of water. Okay, so if mole total number of mole is 1 mole, and then mole of H2SO4 is 0.5. In other words to say, number of mole of H2O in this case also equal to 0.5, because we know that mole of water and mole of H2SO4 equal to 1 mole. So with the mole of water, we will able to determine the mass of water, which is 0.5 mole multiplied with 18 gram per mole, which will equal to 9 gram. But when we want to substitute to here, we have to make sure you divide by 1000. Then you will get the answer. Now let's look at another question. Given a density, again, the density of sulfuric acid solution, okay, so this is density solution, is 1.059 gram per ml, and then the molarity is 1 molar. Again, this time, okay, let's say we didn't want to find the molarity, but we want to find the mass percent. Okay, I will only discuss one of these with you. Okay, so we determine the mass percent. So as we know, the mass percent means that percentage by mass, which equal to mass H2SO4 divided with mass H2SO4 plus mass H2O multiplied with 100%. Okay, next thing that we want to expand will be the density. Again, density solution equal to mass solution over volume solution, which given in the question is 1.509 gram per ml. We have no idea about the mass solution. We also no idea about the volume solution. So when this is the case happen, basically, again, we will have the idea that we may do assumption. However, we cannot so fast to make the decision. Let's check with another one, which is the molarity. So molarity equal to mole of solute, in this case is H2SO4 over volume solution, H2SO4 solution in liter. Okay, I add on back the H2SO4 over here so that you will not confuse. Okay, then next one again, the number of mole of H2SO4 is not given. Volume of solution also not given. Okay, when this is the case happen, so means that we need to do assumption. Okay, but this time when I want to do the assumption, I may assume the volume of the solution. Okay, again, we try to avoid assume the one in the density, but we assume the other concentration measurements. And then always assume the denominator. Okay, so in this case, we assume there is 1 liter sulfuric acid solution. Okay, according to the previous slide we say that we are going to assume there is 1 liter solution, 1 liter H2SO4 solution. So then we can substitute into the molarity. So the molarity multiply with the volume solution will equal to number of mole of H2SO4. Molarity given is 1 mole per liter, and then the volume is 1 liter. So the number of mole of H2SO4 basically is equal to 1 mole. Okay, don't forget per liter and liter cancel out. Okay, then again we want to determine the mass percent. Okay, so don't forget we want to find out mass percent, which is mass H2SO4 over mass H2SO4 solution multiplied by 100%. Yeah. Okay, with the mole of H2SO4, we will able to determine the mass H2SO4, okay, which is 1 times 2 for hydrogen, and then sulfur 32, oxygen 16, plus 4 times 16, which is 64, so will equal to 98 gram. Okay, so we already have 98 gram of mass of sulfuric acid. So next, we need to determine the mass of sulfuric acid solution. So there is no doubt we are going to use the density. So density solution equal to mass solution over volume solution. So density is 1.059, and then mass solution we have no idea yet. Then over the volume of solution. So if you still remember, we assume 1 liter. But here, because the unit is gram per mil, so we have to change the liter to mil, which will equal to 1000 ml. So the mass solution is equal to 1059 gram. So this 1059 gram over here, and the 98 gram will move to here. Then you press the calculator, you will get the answer percentage. Okay, let's continue with the third question with the assumption. So given the density of the solution is 1.3836 gram per mil, and then a mass percent of H2SO4 96%. Find the molarity this time. Okay, so again we want to find the molarity, which is equal to mole of H2SO4 over volume H2SO4 solution in liter. So the density here again is referred to density of solution. Next, we need expand the density solution equal to mass solution over volume solution. We have density 1.836 gram per mil. We have no idea mass solution, also volume solution. Then we try to expand another one, which is percentage by mass, which is equal to mass H2SO4 divided by mass total mass H2SO4 and water multiply with 100%. So again, now here we know the percentage is 96%. We have no idea the mass solution, mass of solute H2SO4, and also have no idea the mass of solution. So again, when density given, another concentration measurement given, we have too much unknown in the formula, so we are going to do assumption. So again, this time we are going to assume mass of solution. Okay, since we want to assume mass of solution, because this one is 96%, so we will assume there is 100 gram H2SO4 solution. When this happens, so you substitute into the formula, mass of solution, percentage by mass is 96%. Okay, and then this one, mass H2SO4 has no idea, but the mass of solution is 100 gram, and then we're going to multiply with 100%. So from here, in general, we have the idea. No need to press the calculator. We also know that 100 and 100 can be cancelled out. Percent and percent can be cancelled out. So mass of H2SO4 will be 96 gram. Okay. So with the 96 gram here, we will able to determine the number of mole of sulfuric acid, which is 96 divided with the 98. This one is gram per mole, and out you will get number of mole. Okay, so don't forget the formula for the molarity is mole of solute over volume of solution. So now we will focus on the volume of solution by using the density of solution. So density solution equal to mass solution over volume solution. So just now we already assume the mass of solution is 100 gram. So we can make over here. So the volume of solution will equal to mass solution, which is 100 gram, divided with the density 1.836 gram per ml. Gram and gram cancel out. So press the calculator. 100 divided by 1.836 will equal to 54.4662. 54.4662 gram. So we need to convert, ml, because this is the volume. So gram and gram cancel out, more mil. So this mil we have to convert to liter, which will equal to 0.05446 liter. So with this, we will able to find molarity, because we have mole of solute over here and we have volume of solution in liter over here. So I will share the answer in the description. Okay, this is the last question that we're going to discuss in this video. So what is the density? So this side the density is unknown of a 3.6 molar aqueous sulfuric acid solution with the percentage by mass 29%. Okay, so as we know, density solution is equal to mass solution over volume solution. So again, we will list out 3.6 molar, which is molarity 3.60 molar, mole of H2SO4 over volume H2SO4 in liter. So from the question, we have no idea number of mole. We also have no idea for the volume of solution. Then next we check with the percentage by mass. 29% will equal to mass H2SO4 over with mass H2SO4 and water multiply with 100%. So again, we also have no idea what is the mass of H2SO4 and also mass of solution. Okay, so for this question, you have to do the assumption, okay, a bit slightly different from what we discussed just now, because just now density is given and then we look for another concentration measurement. So I suggest that you can ignore the density and then assume the denominator of another concentration measurement. So if this is the case happen, actually we have two ways to do the assumption. You can assume the volume of solution 1 liter, or you can assume the mass of solution, assume mass solution 100 gram, or the previous one, assume 1 liter solution. Okay, so we will I will show two methods and then end up you will get the same answer. Okay, so this video might slightly longer than the previous one. Yeah. Okay, as we know that just now we say that we will assume 1 liter solution. So if we have 1 liter solution, so means that we substitute into the molarity. So mole of H2SO4 will equal to molarity 3.6 mole per liter multiply with 1 liter solution. Liter and per liter cancel out, so we will have 3.6 mole. Okay, then from the mole of sulfuric acid, we will able to determine the mass of sulfuric acid, which is 3.6 mole multiplied with 98 gram per mole. Per mole and mole cancel out. So we will get the answer 3.6 multiplied with 98, which is around 352.8 gram. Okay, then next one, because we want to find the density, which we need to know mass solution. So from here we only have mass solute, so we can use the percentage by mass. So 29% equal to density, mass of solute, which is 352.8 gram, divided by mass solution multiplied with 100%. So in this case, mass solution will equal to 352.8 gram divided by 29% and then multiply with 100%. So percent and percent cancel out. So we continue with calculation. 352.8 divided by 29 and then multiply with 100. So we will get the mass of solution is in 1216.55 gram. So we will continue with next slide to get the density. Okay, we proceed with the last part, which we need to determine the density of solution in gram per mole. So just now we have density of solution equal to mass of solution that we get is 1216.55 in the previous slide. And then we also do the assumption that there is 1 liter solution. Due to the question here, specific the volume must be in the unit of ml, so we have to follow. And 1 liter is equal to 1000 ml. So end up divide by 1000, so we will get 1.21655 gram per mole. So if you want to keep it in 3 significant figure, you can give 1.22 gram per mole. So in next slide, I will going to start do the discussion with you at where is to assume the mass of solution. See whether we can get the similar answer for the density of solution. Okay, we repeat using the same question, but do the assumption with another dimension. Okay, previous slide we discussed using the assume 1 liter solution, but this time we are going to assume there is 100 gram H2SO4 solution. So if this is the case happen, so mass of H2SO4 will equal to 29 gram. With the mass of H2SO4 solution, then we will able to determine the number of mole of H2SO4, which is 29 over 98. So 29 over 98 is equal to 0.2959 mole. Okay. After we get the number of mole, then we can apply the number of mole in the molarity. Okay. So molarity is equal to mole solute over volume solution in liter. So volume solution in liter is mole of solute, which is 0.2959 over the molarity given in the question is 3.6. So again, we need to do calculation. 0.2959 divided by 3.6. We get the answer 0.08219 liter. As we want to determine the density, which is in the unit of gram per mole, So gram, just now we get density of the solution is 100 gram. Please remember, don't substitute 29 because we want density solution, which is 100 gram. But the unit here this time they need ml. But what we get is in liter. So we will multiply with 1000, which will equal to 82.19 ml. So press the calculator again. 100 divided with 82.19. Yes, we will get around 1.216 gram per mil, which is similar to 1.22 gram per mil. So I hope after discuss these 4 questions with the assumption with you, you have better idea what should you do when you need to do the assumption. Okay, basically we need to do the assumption if in one formula there is 2 unknown. Okay, always assume the denominator. Dalam bahasa we call penyebut. Okay, then if you are given, after you do the assumption, when you get the mass, normally you can use the mass to determine the number of mole. Or another way around, if you can get the number of mole, then you also will able to determine the mass. Okay, I will share the answer in the description. See you in next video. Bye bye.